Dan Olds here. I'm with Bo Paisley with Alinea. How you doing, Bo?
Great, thank you, Dan.
And we go way back to, what, maybe 3 minutes ago when we met?
About 3 minutes, maybe
About
4 now.
About 3 minutes. It's good. It's been a good relationship. The reason that I wanted to stop by here to talk to you guys is that you help ease that transition from CPU-based computing to hybrid computing with CPUs and GPUs, right?
Absolutely, we certainly do, Dan.
And what are the problems there?
Well, as you move from CPU code to GPU code, it's a very different architecture. And traditionally, the exercise of getting your code going on GPU means new tools, new methodologies, and a different approach. But with the Alinea tools, the environment looks the same and behaves the same as users are already familiar with running on the CPU. So as you integrate the CPU either in a workstation model or in a cluster model, debugging on the GPU is very similar to as if you were on the CPU in the model you might already be familiar with.
And the real problem, well, one of the real problems, is trying to really get in and take advantage of all that parallelism that you can get with a GPU.
It certainly is. That's.
I mean, why use it if you're not going to get a lot out of it?
Absolutely, that's right. And if you're not getting the parallelism out of it, you might actually be losing performance. And given the different architecture, getting your code to work in that way is a big challenge. So with the debugger, not only is it a tool to find problems in your code and where items are going wrong, but it's a really powerful tool to study your algorithm and see, is it working as I want? Is it doing the right thing? And am I getting the type of performance improvements that I think I should get? And it gives a lot of visual feedback, very easy way to inspect the code. So not just a debugging tool, but really helpful in studying.
It's a profiling tool.
It provides both profiling and debugging, and not just profiling in the sense of how did my code run, but on the GPU it often involves studying what is the code path of the execution, how is my algorithm behaving, and that the way it works is so different than what we're familiar with on the CPU. It really helps to understand the execution path as you're going along.
And one thing that I am intimately familiar with is these student cluster competitions where in 2009, no one used accelerators. 2010, a few teams, and most recently, they're all using accelerators, and they're all kind of struggling with this. How do we get the most performance out of them? Because a lot of times there aren't quick and easy GPU versions of some of these codes they're asked to run. And they need to understand and use profiling, I think. That's where it would really come in handy, right?
Oh, absolutely. It's nothing's for free. So as we were porting to these coprocessors, there was a lot of hope early on of like, oh, we'll just compile for this thing.
Just recompile and we're good. It's the same thing with Phi. You've got to do
some work.
You can't just recompile and go.
Absolutely. The Phi has a lot of potential, and that's another device that we support, and we're seeing a lot of uptake. But it's not free. You got to do some work to get the performance out of these devices, both GPU and the Phi cards, and using a profiler to really narrow down where your code now has bottlenecks on the coprocessor is very important to get the utility out of this additional hardware.
I mean, some of these applications, like they were running, let me think. My mind just suddenly went blank, but I think they were running GraphLab. That was it. And they were having problems getting it optimized on GPUs. They were getting some of the benefit, but not all the benefit. And I think doing some profiling, starting there, and attacking those bottlenecks one by one would have probably paid off.
Oh, absolutely. I think, as we're porting codes to especially the GPU with such a dramatically different architecture, need to bring up at a high level of where are the new hotspots, and they're going to be different than what we saw on the CPU or another device, and then home in on which ones have potential, which ones can we greatly improve, and use a very focused approach. And that's where Alinea Map, I think, really helps a lot, in that it starts with a high-level view of your entire application and the nature of performance across your entire application, so you don't focus on the wrong areas. I think it's easy to say, I think I know what's slow, but on the GPU, we don't really know.
But let's find out where it's slow.
We need to find out. Let's focus our efforts
on the right places
where they're going to pay off.
It might be kind of interesting if you guys are interested that we could do a webcast sometime and walk students through, or whoever wants to watch, but walk people through what it's like to use like Alinea map and then the performance reports, the profiling, and show them what it looks like.
I think that'd be well worthwhile. We'd enjoy doing that, Dan.
Yeah.
Absolutely.
Yeah, we will investigate that. That's a
Great,
good idea.
I appreciate that.
We've got a lot of cluster activity happening this year, a lot of competitions. I want to give them all the help we can.
Absolutely.
Well, thank you, Bo. Really appreciate the time.
Yes, thank you, Dan.